The oxygen dissociation curve looks at how partial pressure affects the saturation of hemoglobin. We can see at higher partial pressures of oxygen, there's a higher saturation of hemoglobin. The graph is curved due to the structure of hemoglobin, which is made up of 4 polypeptide chains which can bond with 4 oxygen atoms. According to medical exam prep, the oxygen dissociation curve has a sigmoid shape because of the cooperative binding of oxygen to the 4 polypeptide chains. pH and temperature, so increased carbon dioxide in the bloodstream when exercising causes a decrease in pH, and there's also an increase in the body's temperature. These factors combined to increase the amount of oxygen released by hemoglobin to the working muscles, and this makes the curve move to the right, and it's known as the Bohr effect. Oxygen saturation, so we can see all 3 test subjects had an oxygen saturation level of 98 to 100% in minutes 1 to 16. This shows that the subjects were working aerobically as they had high hemoglobin saturation. You can see that Morgan and Asheen continue to work in this range for the whole 20 minutes. However, Evelyn has a drop in oxygen saturation at minute 16 to around 67% by the end of the 20 minutes. The heart rate data in all 3 subjects, we see an increase in heart rate within the first minute, which then plateaus after the first minute. There was an 18% increase, so an average of 150 minutes BPM in all 3 subjects. We can then see they plateaued, all 3 subjects plateaued from minute 2 to 20, and they all stayed in the 130 to 180 beats per minute range, suggesting they were working aerobically for most of the time. For blood pressure data, we can see Morgan's blood pressure data decreases from 150 to around 72. We then see that after this drop, it increases to 160 by the end of the 20 minutes. And the diastolic pressure starts at around 95 and decreases to 50 at minute 8. Pressure then increases to 75 at minute 16 and then decreases to 50 by the end of the 20 minutes. This is slightly different to what we would expect during aerobic exercise, as we expect the systolic pressure to slightly increase and the diastolic pressure to slightly decrease. In Osheen's data, we can see the blood pressure slightly increases from pre-exercise of 140 to 150 by the end of the 20 minutes, which is what we would expect. The diastolic pressure decreases from 100 to 85, which is what we would expect, a small decrease. Evelyn's data, systolic pressure starts at 95. We then see a decrease in systolic pressure from 140 to 45 by the end of by minute 20. The diastolic pressure starts at around 70 per exercise. We then see a decrease in diastolic pressure from around 45 to 20 minutes. This is slightly different to what we would expect as the systolic pressure decreased. However, the diastolic pressure also decreased, which is what we would expect, but there were for diastolic pressure. For lactate levels, we can see Osheen's started off at very high, level of 23 in the 3rd minute. By the 12th minute, we can see the lactate levels significantly decreased to around 7th by the 12th minute, and then by the 18th minute, the lactate level was around 6. This is slightly different to what we would expect, so we would expect the lactate to stay the same. Morgan started off with a lactate of 7 pre-exercise, which then rose to 12th in the 8th minute. After the exercise was started, the lactate then decreased to 7th by the 12th minute. These results are slightly different to what we would expect, as the lactate increased during the 20 minutes, suggesting she might have not been working aerobically. Evelyn's lactate level had a lactate level of 13 in the 4th minute. After exercise started, we then saw in the 18th minute it dropped to 6. These results are slightly different to what we would expect, as we expect the lactate. Different to what we would expect, as the lactate level decreased during the 20 minutes, which is where it should stay a similar level. For the ball scale, we can see Osheen started off with the lowest number being 6, which slowly increased over the 20 minutes. By the end, had a 12 on the ball scale. Morgan started off with 8, which increased to the highest point of 14 in the 14th minute. We then saw a decrease back to 10 down in the 18th minute, which continued at this level to the 20th minute. Evelyn started off with the board scale 9, which then increased to a number 11 on the scale in the 6th minute. We then see a drop down to 10 in the 8th minute, which then increases again to 11th in the 9th minute, which then stays at 11 for the rest of the 20 minutes. On average, I don't think they do. They don't fully match the data as it slightly increases, which we wouldn't expect. However, the ball scale was very subjective, and the they could have been getting more tired as time went along, so this could affect their results. So breathing rate data in all 3 subjects, we saw an average increase of 18 in breathing rate from the start, from the 3 minutes. We then see a plateau in the subject's breathing rate. Morgan and Machines plateaus for most of the 20 minutes and stays in the 17 to 20 breaths per range for the whole time. Evelyn's plateaus from minutes 6 to 12, staying in the 50 to 53 breaths per minute range. We then see a decrease in this point, where in the 20th minute the breathing rate decreases to 32. Oisin plateaus from minute 2 to 8, staying in the 27 to 30 breaths per minute range. However, after the 8th minute, we see an increase in breathing rate, and in the 20th minute, it reaches 40 breaths per minute. The cardiovascular system analysis, we see that the hypothesis for heart rate is that it will plateau within the 20 minutes and the heart rate will increase during the first 3 minutes. We measured heart rate every minute of the 20 minutes using heart rate monitor to measure beats per minute. This let us see how fast the heart was pumping blood to the working muscles, and lets us see if we're working aerobically. The normative data suggests that the heart rate would increase during the first 3 minutes and then plateau for the next 17 minutes of exercise. When exercise stops, there should be a fairly quick decrease in heart rate back to baseline level. When doing steady state exercise, we would expect the heart rate to be between 150 beats per minute to 177 beats per minute, as this is the average heart rate for their age during steady state exercise. This was worked out using the Carve and Then formula. These are the results that I gathered from testing were in this range of normative data throughout the 20 minutes. None of the subjects' heart rates on average went above or below this range. An example of this would be in the 9th minute, where the average heart rate of all 3 subjects was 160.6. We then see in the 14th minute it was 166.3, and in the 18th it was 163.3. These results show minimal increase or decrease throughout the 20 minutes, creating a plateau. Also, during the plateau, the subject stayed within 130 to 180 beats per minute, suggesting they were working aerobically most of the time and proving our hypothesis. This suggests that they were working aerobically. We also recorded other data such as breathing rate, which we saw a plateau in. We recorded board scale every 2 minutes to see if the subjects thought they were working hard. We could compare this data to heart rate, as none of the subjects had outrageously high board scale. However, it did increase, but none of it was extremely high, and their heart rate wasn't extremely high, suggesting that they were working aerobically. We could also expect an increase within the first 3 minutes, and this was shown as there was an average of 18% increase in heart rate to an 18% increase in heart rate to an average of 157 BPM in all 3 subjects. This proves our hypothesis that heart rate would increase within the first 3 minutes. For energy systems, our hypothesis for energy systems is that the aerobic glycolytic system will be used, and that little amounts of lactate in the range of 2 to 4 would be present in the bloodstream. We also expect oxygen levels to stay between 95 and 100%. The energy system used, we would expect the aerobic glycolytic system to be used when aerobically exercising. To find this out, we carried out various tests in lactate, such as testing lactate levels in the minutes of 3, 12, and 18 using a lactate monitor. We picked these minutes as it showed we could see a change in lactate over the 20 minutes to see if we could see a change. I expect there to be low lactate present in the bloodstream, and there should be no lactate increase when working aerobically. But if there is an increase, it suggests they're working anaerobically. The normative data for lactate is 2 to 4. Our lactate measurements did not match up with normative data, as all the readings were above the 2 to 4 range throughout the whole 20 minutes of the test. This is shown in the first reading by everyone, which everyone took of the first reading that everyone took of lactate, which was the average of all 3 of them was 14.6 lactate level, which is extremely high. We then saw an average decrease to around 7 by all, an average of 7 by all the subjects in the third reading of lactate. This shows an average decrease of 7.6 in lactate from the first reading of lactate. Compared to this shows an average decrease of 7.6 from the first to the third reading of lactate. This isn't what we'd expect, as we expect the lactate to stay at a similar rate. Factors that could have influenced this is that cycling is that some of the subjects cycled to college. This could increase lactate levels, and they did physical activity the day before the test, so this could have affected the lactate levels. These factors could influence it by increasing the lactate. We also measured oxygen saturation before. By doing this, we also measured oxygen saturation every 2 minutes using oxygen saturation monitor. The normative data is between 95 and 100%. All three of the subjects stayed in this range, suggesting that they were working aerobically. However, there was an anomaly in Evelyn's data where it decreased, where we saw a drop in oxygen saturation to around 67% by the end of the 20 minutes. This drop in Evelyn's data could be seen as an anomaly, as her level of breathing rate, heart rate, and board scale did not match with this data. A breathing rate analysis, the hypothesis that the breathing rate would plateau during the 20 minutes, and there'll be an average increase. There'll be an increase in breathing rate during the first 3 minutes. Breathing rate was measured for 2 minutes throughout the experiment by counting how many breaths there were by the subjects. This allows us to analyze the subject and see how intensely they're working to get an idea of whether they're working aerobically or not. If the subject has a very high breathing rate, then it suggests they aren't working aerobically, as they have an oxygen dip. When steady state exercise occurs, we expect to see an increase and then a plateau in the breathing rate. After exercise, we expect it to decrease quickly to baseline. In the first 3 minutes of exercise, we saw that there was an average increase of 18 breaths, and this supports our hypothesis, as we expect to see an increase in breathing rate in the first 3 minutes. We then saw a plateau in all three subjects, which supports our hypothesis. Morgan plateaued for most of the 20 minutes, staying in the 17 to 20 breaths per minute range. Evelyn's data shows a plateau in minutes 6 to 12, where she stayed in the 50 to 53 breaths per minute range. Oshin from minutes 2 to 8 was staying in the 27 to 30 breaths per minute range. However, Oshin's data showed an increase in breathing rate to 40 by the 20th minute. This increase does not support our hypothesis, as when working aerobically, there shouldn't be a massive increase in breathing rate. The normative data for breathing rate when working aerobically is 30 to 40 breaths. Our data does not match this, as Evelyn's breathing rate reached 50 breaths per minute, which is above this range. Morgan's data is below this, as the highest breathing rate she reached was 20. Oshin's was in this range from the 6th to 20th minute. So this would stay within the normative data. Some factors that could affect this are fitness levels and emotions such as anxiety, which could increase breathing rate, suggesting why they're not in the normal range. So does our data reflect our hypothesis? For heart rate, I think that our data did prove our hypothesis. As we can see, on average, there was an increase in heart rate for all three subjects within the first 3 minutes. We also saw a plateau at some point within the 20th minute. For breathing rate, I think our data mostly proved our hypothesis, as there was a breathing rate increase within the first 3 minutes, and we saw a plateau in all three subjects. However, some of the breathing rate was higher than we would expect, and Oshin's did increase at some point. For energy systems, we think the data mostly didn't match our hypothesis, as the subjects had very unusual data. We saw Oshin had a very high lactate, which then decreased. Morgan's lactate increased as well, and Evelyn's showed a decrease over the 20 minutes, which is unexpected and doesn't really match our hypothesis. All our subjects were above the normative data for lactate. However, we did see the oxygen saturation data did match normative data, which could suggest that they were working aerobically. However, in Evelyn's data, we did see a large decrease in oxygen saturation, which wouldn't support our hypothesis.